Uh, Hello. Hello, Krakow. Hello, programmers from whole Poland. I'm Alexey Zinovyev, Java trainer in EPAM company. Today I will tell you about Thorny path to data mining projects. Maybe I will talk so many buzzwords and etc. But please don't worry, this is only keynote, and I need to help you in order to hear really hard lectures. Okay, why am I speaking about, I know, data mining? Because I'm a graph theory, machine learning enthusiast, traffic jam prediction is area of my interest, and maybe some big data algorithms and etc. But also, this science is not my main area of responsibility. I'm a Java programmer too, and I use NoSQL, Hadoop, Spark, and etc. in my current maybe project and previous project when I worked like a backend programmer. Okay, what do I know about Krakow? I understand that you all know what Krakow is, but for me it's maybe something people in old national costumes, old churches here, and etc. But in reality, I don't think about Krakow yet. But what did I know about the Poland? I know that you have a bigos. Bigos is special and taste, and I found some rows from your national poet Adam Mickiewicz w kaczelkach bigos gdziano, w słowach wydać trudno, bigosu szmak przeżywny, kolor i won cudna. And how it's a difficult yeah. Uh, and how it's difficult to find the meat and bigos, the pattern discovering is so difficult in data mining, in my opinion. But the true story about the Poland, as I see in my previous story, these are Polish programmers who won a championship. Maybe it's named like Hello World, I don't know, but it was a real championship of programmers. And my previous colleagues were Polish guys, testers, programmers, and etc. And I really to hear you, see you here. And this topic, a lot of strange picture and technologies from Hadoop, Crazy Zoo, and etc. We will talk about data mining, Hadoop ecosystem, Spark and its friends, and of course about machine learning libraries. But how many people here, not maybe Hadoop developers, let's vote for the, who heard about Hadoop? Okay, not all, nie wszystko. But are you a Hadoop developer? Please raise your hand. Cool. Oh, I see you. Hey, brother. Yeah, maybe a few topics can be strange because I don't want to tell you what MapReduce algorithm is, and I have a reason for that. Okay, let's do this. The good old days, then all of you were Java programmers. You, of course, had a manager, and one of these fine days, your manager invited you in your cabinet and you in his room, and he said, "We need Python developers because we have a data mining project, but you are Java EE developer only. Continue write you backend, dude. But let's talk about it, Java boy. What's the problem? Can a Java programmers can be a data scientist?" This is a good question. But can be a data scientist be a Java programmer? All we know that sexy is data scientist profession now. We can hear something about that many people can discover new formulas and write it into the desk. But in reality, the real data scientist in many areas, this is a student from high school and he knows maybe a few algorithms, he learned some papers, but in reality, he has a very small experience in development. Maybe he can write some Python code or a language code, but in reality, he had no deal with real Java production, with Java beans in reality. And what I tell you, young man, you shall not pass here. What is data mining? Maybe is it statistics? Of course, if you want to become a data miner, you should know all statistician formulas, Bayes theorem, laws of theory of probabilities, and so on. Maybe the math or applied math faculty is enough for that. But this is only top of the real production iceberg. In reality, your managers want reporting. And of course, they are not interested in real pattern discovery, in real formulas. They need facts for their customer value or something else. And in many cases, you can use all of cubes with many slices. Do you know Mandarin library to build all of cubes? Okay, maybe somebody. I see. Okay, yeah, it exists. But in reality, what's the difference between reporting and data mining? Data mining, this is a building of new facts, but reporting, you can merge something in one column and etc. Okay, let's start from the simple example. Before my flight to the Krakow, I tried to find the average temperature here, and I found that average temperature, the low average temperature, average low is 8 for October and 16 as a high mark. But you see the weather. Why our weather services cannot predict that? This is easy. You have historical data. You can extract some features from, I don't know, timestamps, the numerical data like temperature and so on. And can you predict it? But they use only simple statistician formulas, and this is bad. You can train yourself by, I don't know, you can get weather of 19th century, can predict something in 1901 year, and you can verify your results by real weather in this year. For example, you can involve more features. I'm not sure that you see in this slide, but it was copied from Krakow, Wikipedia maybe. We can extract some features like max temperature, wet days, day length, I don't know, sun shining, and etc. But in reality, the weather prediction is bad. The next task, we should classify two images. Of course, we are humans and we can classify, but the machine cannot, because they are too similar. They have, I don't know, similar weight, maybe, similar sizes, and maybe similar color. If you're sitting there so long. Sorry about that. And now this is time for Java superhero. Before pattern discovering, this is a very practice thing of all data scientists. The real data scientists need in Java programmers, then they should select small pieces from the different data sources, define default values for missed data, remove strange signals from data. For example, I know somebody measured temperature 2 days ago, like, I don't know, 100 degrees above the zero. It's a strange signal, we should remove it. And merge some tables in one if required. And if these tables are large, we should merge it in large memory, but we cannot rule this memory through the Python or through the R language. We can rule this memory through the Java or C++. Let's talk about subject area. Not so many, but we should discuss it. What's a typical question for data miner? For example, which loan applicants are high risk? This is a typical question. How do we detect phone card fraud, for example? Or what's the revenue prediction for next year? This is a good example. Then you want to start in company which have no deal with data mining. You can suggest your power and predict revenue. This is very important for customers, for your managers, for business, and maybe they will share his data for you for prediction, but of course without salary. Can you recommend music for users? This is a good question. I know that in Poland is very popular Facebook. Would you like Facebook music recommendation or YouTube video recommendation? Really? No, nobody? Okay, maybe now the services, I'm not sure. But in reality, all algorithms of music recommendation are using data mining algorithms in order to extract some features from your user profiles, in order to, I don't know, make you person like a man who likes this kind of music but dislike this kind of music. And what the data can be grabbed? Of course, we can grab our data from the different data sets. For example, Facebook users at Wins is very interesting and many people want to do something with that. But in reality, it's, it's not so predictable, as you see. It's possible to use in social network analysis, for example. In banking sphere, we can get trade transaction data. And this is very interesting for banks, but maybe not so interesting for you. But you can win, for example, championship from this bank and train yourself on these congresses. For example, the medicine data and telecommunications. But what kind of data sources can be? Relation databases, of course, we shouldn't forget about this, and we shouldn't use Hibernate not to extract some features, because in many cases you should optimize it. So the size of databases here can be so big. Data warehouses, this is historical data, sequential files. It's very easy for reading, but maybe not so easy for filtering. Of course, it's files in CSV or in binary formats, because I know that Java developers don't like to parse maybe CSV files in many enterprise systems. But here it's interesting, believe me. Maybe the tones of internet and electronic mails, you heard something about the scandals, then somebody hacked different mails and grabbed it and extract some features from there. And of course, it's scientific research formats. This is the hardest thing here, because all data scientists try to get PhD in this sphere and prepare their own format. The pattern mining. Of course, we can start from the simple association rule learning. This is very easy. It's based on the Bayesian rules. And for example, then you go to the shop, or then you go to the electronic market, you can find something and the system can recommend you the similar object. Or it can be not similar on the previous object, but it can be suggested for you because the similar users bought it. The next task, cluster analysis. Cluster analysis, maybe somebody seen this picture from the Coursera course. It's very easy to train cluster analysis here, but in many other cases, in reality, this is the most popular case in data mining projects, because you have no labels of the classes. You have no classes yet. You should to divide, I don't know, raw data on different parts. And the process can be very interesting, and the results can be different. For example, different algorithms can give you different results. You can see Kamins, DB-scan, spectral clustering, and etc. And you can see that 3 data sets can be divided on different clusters by different algorithms. And the power of your brains to interpret these results, this is a part of data scientist job. If this is job for you, you can start. Okay. The simplest thing, regression. I'm not sure about your educational program, but if you finished, I don't know, math faculties or something else, maybe you had this, I don't know, something in your program, then you should put the line from different points and approximate these points by the, I don't know, by the simple line, maybe through the polynomial line, and maybe through the, I don't know, special curve with many laws. Classification task. This is very easy, and in the Kaggle competitions, do you know Kaggle competition? This is a famous competition of data scientists. You can start here, but maybe only in Python. All people really like this task, classification. Then you should classify something. You have a training set of classified examples. For example, I don't know, red dots and blue dots, and you have a test set of non-classified items. You should classify them. In real cases, you can have answers, but in many cases you can have not. And of course, the main goal here, find a function classifier that maps input data to a category, a class. Maybe classifiers are not so interesting. Let's go to the decision trees. You can see this picture from the I don't know, Titanic film preparation, and was a question, who will survive on the Titanic? It depends from three features: the sex, the age, and the SIBSP. What does it mean, a SIBSP? Maybe it's crazy Russian word. No, this is abbreviation. Means that the number of member of your family on the ship, and if this more than 2.5, you have good chances to survive. But in reality, we know that maybe class tickets can really influence and that, if you remember film. But data scientists found the real facts. Okay, let's talk about KNN. This is the simplest algorithm, and if you use different Java libraries for that, I don't know, for different algorithms, here you can implement it by yourself. It's very easy. What the k-nearest neighbor algorithm means. For example, you have green circle, and we should to define what is it? Is it a blue square or red triangle? Let's ask its neighbors. Firstly, we can get, I don't know, 3 neighbors. If we get 3 neighbors, 2 red triangles influence on green circle, and of course, green circle is a red triangle. But if we get 5 neighbors or more, maybe blue squares will influence on that, on his orientation or something else. Okay, let's finish with algorithms. Let's talk about fashion languages and libraries. Of course, many data scientists can start with Octave. This is a clone of MATLAB. This is a free and open source, but in reality, it has small amount of ML algorithms, machine learning algorithms. It has single thread model. Yes, it has Java support, and you can call Octave functions through the Java native API, but it's too sad. This is a user interface of typical R Studio, and why not R language? Because the part of R packs are written in Java. Because syntax is too sweet, of course, you can write your code, but after, I don't know, 1 month, you can forget all about that, and you need to self-documentation here. And of course, it supports only single thread model for many algorithms, no parallel implementation. Why not Python? Python is real ideal for young scientists due to the low barrier to entry, but in reality it's high-level language, and if you, I don't know, heard about Gton, in many projects people use these in order to run on GVM because they need some GVM power here, but if you need a GVM power, maybe you should use Java or Scala. And of course, we are not Python developers, but Python has 2 good libraries, Pandas and scikit-learn, but we have implementation of this interface in Java. Let's think in Java way. Java ecosystem. The typical true story about 2 Hadoop developers, then 2 Hadoop developers meet, they can describe the cluster size. You heard that I have, I don't know, 100 machines, but I have 200 machines, and this is so on. But in reality, how to make features from Hadoop cluster. This is interesting on data mining research project. You can use Hive or Peak. For example, Hive supports SQL-like syntax, but Peak maybe is more preferable for Java developers because it has, I don't know, like pipeline API. You can transform your data from sources to the end, to the result, and you can use join for each and etc. Do we need a special graph approach when we have deal with graph? For example, in social network analysis, how to make graph features? I don't know. For example, to detect communities in university, you couldn't use MapReduce for iterative calculation because high complexity of graph problem, you know, it's very rude to reduce it to k-value model. Iteration algorithms can be presented in Hadoop like a chain of jobs in MapReduce style with full saving on the disk and reading from disk of each state. This is not good for iterative algorithms. And if Hadoop and Spark suggest, I don't know, dividing of data, different calculations and merging of results, the graph parallel approach implemented in GraphLab and Giraffe suggested another way to divide graph. You should duplicate some data. The vertices can receive messages, can send the messages, and so on. It reminds me, I don't know, task of shortest path. I have data. What else? Of course. What about the GDM? GDM, this is a Java API for data mining. You can see the old number of GSR, a real old number, only 2 digits. And of course, Java has JavaX data mining supervised interfaces. It defines all algorithms, but there are no good implementation for that. Of course, GDM2 adds text mining, time series, and so on. But the another reason that it doesn't support parallelized algorithms here. But who knows Weka? Who knows Weka? Whoa, I see. Not so many Hadoop developers, but you know Weka. Cool. You know Bird or Studio? Okay, I see. Of course, Weka is cool studio for data miners, for people who want to play in sandbox maybe, or if he, I don't know, not very big data set. It has connectors to R, Octave, MATLAB, Hadoop, NoSQL, SQL system, and so on. And the main feature here that you can get source code of all algorithms in Java. I don't know, get a jar, including your project with train model. It's easy to retrain it, and so on. This is not so pretty because it's Swing, of course, but Swing is not so pretty. But this is a visual studio for you data mining process. SPMF, maybe it's not very popular library, but this is a, I don't know, this is a child of many data scientists who really cool in Java, and they implemented more than 100 algorithms, but not so many classification algorithms. They are concentrated on the pattern discovering maybe, but it has cool performance results, and you can find these performance results if you Google it, SPMF. Mahout, it was the coolest thing, I don't know, 1 or 2 years ago, then the MapReduce was on the top, but now they decided to provide support maybe for Spark implementation only, because okay, let's talk later maybe about Spark. New algorithms will build on Spark platform only, and you has now the current situation. Old algorithms are implemented in MapReduce style, and new algorithms are implemented in Spark platform. But the new way here to implement all algorithms on Samsara platform. If you will download it, please use Samsara here. Code sample Mahout. In reality, you can use Mahout in your project like, I don't know, microservice or something else which can be installed through the command line. But of course, you can use it through the Java code, but in many processes, you should use command line. Let's see on this crazy zoo. The Hadoop ecosystem, HDFS at the bottom, MapReduce approach here, Hadoop, whoa. Maybe the end of the lecture, Hadoop, and the Hive, Mahout, and etc. in order to extract features here. But Hadoop is not sexy here. And what? If you are started to learn Hadoop, I don't know, 2 weeks ago, can you reduce the sound? If you started to learn Hadoop, I don't know, 2 weeks ago, or I don't know, 1 month ago, please stop it. It's very interesting for old projects, but on the new project, you should learn the Spark. MapReduce job writing in reality, it's like, I don't know, you do something with did elephant, you write very crazy Java code with specific types defined for this framework, and there are a lot of Hadoop services which communicates through the low-level interfaces. But what we can get from the Hadoop, it can be Yarn, the skeleton, the special platform in order to parallelize Java code, data, and so on. Spark is the bloody son of MapReduce approach. It can be presented like a MapReduce approach in memory. For example, I don't know, some marketing words that it speed up to 50 times faster than Hadoop. In my real project, I have 10 or 20 times in reality. And then you have deal with Spark. You implement all Java code through the Java API or through the Scala if you want. based on the pipeline style. You have a RDD, like a mutable distribution collection of object, and you don't think about really distribution of this object on the different machines. Mahout's killer. We talk that Mahout, yes, it can be not so good, but it has Spark support for new algorithms. But we have special library which supports only Spark. MLLeap. It supports classification regression, collaborative filtering, clustering, dimensional reduction, and of course for seniors optimization. Got a sample of MLLeap, for example, for k-means. It's very easy. You can define parameters. You have a special RDD here, and you can call a k-mean algorithm and call the method which can provide you a RDD collection after all evaluation. MLLeap extends Python libraries and Mahout interfaces. I think it runs fully on Spark only, it's very well documented, and it's well for large data sets and parallelized algorithms. But if in reality you want to get a small prototype, please don't use MLLeap for this goal, because you will have so many cost objects for your parallelization, and you will shuffle it between different servers, and this is not a good way if you have no goal to parallelize your code. Okay, maybe it solves all problems. Maybe. In conclusion, I try to inspire you at the end. Think about your data. Then you're a data scientist. You should think about your data. You should forgive about refactoring. You can forgive about refactoring. Maybe it's good news. You should have friendship with DevOps engineer, because in reality you will have no time to optimize Hadoop cluster, different settings, I don't know, to increase your Java memory and so on. You should run Spark for the new projects. You should learn algorithms, because if you will be only a Java developer who can run Spark or Hadoop, it will be nice, but then your data scientist share his Python code with, I don't know, scikit-learn interfaces, and you will need to copy it into Java. You should understand what he wanted to do, and maybe you can improve his results. And of course, please write Java code. Don't use Python, R language, and so on, because you have parallelized libraries in Java. Okay, hold your data and go ahead. Okay. Call me if you want to know more, if you have any questions. Of course, maybe no time to question now. I will be here, maybe here, maybe here. You can find me. Thank you.
Do you have any questions?